This is Physics 2212, Lab 2, Charge Tape Revisited. In this lab report, I will first introduce the experiment and then explain the computational model and code. I will then follow with the results, discussion, and the conclusion. The purpose of this lab is to revisit the topic of charge tapes and calculate the magnitude of the charge on the pieces of tape while assuming that the charge is distributed evenly across the length of the tape. This will be achieved using a computational GlowScript program. The fundamental principles include Coulomb's law and the force of gravity. Coulomb's law is shown on the slide, and the value for Coulomb's constant is on the right. The r vector represents the vector from the source to the observation location. The equation for the electric field of a uniformly charged rod is also shown, where the rod is treated as a collection of point charges and the observation location is perpendicular to the rod and at the halfway point of the rod. The relationship between force, charge, and the electric field is also shown. The force of gravity is the downward force exerted by the Earth, and it is negative mg y hat, where m is the mass of the object and g is a constant equaling 9.8 meters per second squared. A preview of the result of this lab is that the charge tape is positive with a charge of 2.459 times 10 to the negative 8 coulombs. This value is nearly double that of the lab 1 value, which was 1.38 times 10 to the negative 8 coulombs. The experiment information is presented on the slide. The separation distance was 0.03 meters, the length of tape A and B was 0.195 meters, and the mass of tape B was 1.95 times 10 to the negative 4 kilograms. The system is tape B and the surroundings are tape A, the Earth, and everything else. The key assumptions of this lab are that the tape's charge is assumed to be evenly distributed along its length and that both the tapes have the same net charge. The air resistance key assumption is not key to this experiment because the floating tape B is suspended. The overview of the procedure and observations from Lab 1 are provided here for completeness. We know from the previous experiment that the charged tapes are positively charged. Here are the calculations and code from the experiment. The constants used are presented on the top left, and importantly, the calculation for the estimated charge value is shown in the bottom left. Because tape B is suspended and motionless, the net force on it is 0. Thus, the gravitational force must be equal to the electric force in magnitude. So mg is equal to the electric force. To get the force, the charge is multiplied by the electric field equation for a uniformly charged rod shown in the introduction, rearranged to solve for Q. As for the code, the defined E field function is shown in the top right, and the iterative calculations of the electric force on the top tape due to the bottom tape is shown in the main image. The code for the line charge arrows are also shown at the bottom of the slide. Here is the result of the Python code. The magnitudes of the electric force and gravitational force are shown in the image of the result of the code. They are slightly unequal as the code required varying the n value, which affected the total electric force calculation of the numerous point charges along the length of the tapes. Any error present in the estimated charge value would have compounded over the iterations, resulting in an electric force value that is slightly inaccurate. Some trial and error with changing the estimated charge value or a very large value of n may result in less disparity between the force values. Lastly, for the results, discussion, and conclusion, the tape is positively charged, so there is an electron deficiency. The charge of the tape is 2.549 times 10 to the negative coulombs. This is nearly double the value found in Lab 1, likely due to the limiting assumption that the tapes act as point charges. The possible sources of error in this experiment include inaccurate measurements of the tape length and width, and importantly, the separation distance, as well as rounding error that may have compounded during the iterative computational calculations. As for the additional questions, what if you had modeled the tapes as point charges? Compare your point charge and line charge values. The Lab 1 charge value was 1.38 times 10 to the negative 8 coulombs, and the Lab 2 Q value is 2.549 times 10 to the negative 8 coulombs. The difference is a factor of 1.847, and the line charge model estimates a larger value of positive charge. Why do these estimates differ? Which value is likely closer to the real value and why? The line charge model is likely closer to the real value because it considers the length of the rod and the separation distance, and the assumption of a uniformly charged rod is much more realistic than the point charge assumption. That's all. Thank you.